So, okay, so this is the assignment today. I'm going over the notes. It says April 2nd, but you may be doing it on a different day. So the first thing is these first three questions are example questions that'll show up on the assignment. Okay, the answers are below, but we're not going to look at them yet. Okay, the first thing is to make sure you read the scenario of what data they're giving you here. Oysters, years since 1900. Anyway, you always want to take a moment to read through it, make sure you understand it. Oysters harvested each year, but it's not. But it's interesting because it's not like 1903. It's years. Well, that would be 1903, wouldn't it? Okay, so they're keeping track of the. I guess the X is the first column and the Y is the second. Now, then we're given a model that models that data, and it's listed as you can see, the 45.7, and then X is the number of years since 1900, and Y is the amount of oysters harvested. I think the first thing in doing these kind of questions is making sure you're keeping track of what the independent and dependent variables are. What I mean by that is they're saying X is the first column. It's the years. The second column is the amount of oysters. So that'd be like the Y. You're also given a graph, right? So years since 1900, that'd be like the X and the, come on. And the Y would be the oysters in tons. All right, so once you're straight on what everything represents, the graph, the equation, and what they're saying in the table, now you can answer the question. So using the model, how many metric tons of oysters were harvested in 1940? Again, we're using the model, not the table. And then round your answer to the nearest tenth. So there's two ways we can do it. We can actually use the model, the equation, or we can kind of use the graph. Now, if I use the graph, that seems like it'd be pretty easy, but what I would do is I would go to 1940. Now, by the way, we see 1940 on the x-axis. So we're looking for 1940. The years are on the x-axis, or on the horizontal axis. Do we see 1940 on that? I don't see 1940. I see 20, 40, 60. Peyton, what would be 1940 then? Okay, because it's years since, right? So you'd have to subtract 1900. Yeah, exactly right. So it's the year since 1900. So really that 40 is like 1940. So it's a little bit weird. Now, if I go to the table, I don't see 40 over there, do we? We don't see 40. So we can't use the table. But again, we wouldn't use that anyway. We're using the model. So it's either going to be that line, the curve that we see, the blue one, or it's going to be the equation. If we use a curve, we'd go there, and it looks like it's a bit between about, geez, we'd have to guesstimate, right? It's in between 10 and 20. It's less than 15 because 15 would be that line. So maybe about 12. But guess what? There's three different answer choices that would work. It's definitely above 10, so I could knock out the D. But now we're going to have to use the equation, which is right here, right? So now we're going to take this equation, and we're going to go 45.7. And that little tiny dot in between them is multiplication, okay? So it's like this. Gosh dang it, my pen's running out on me. There we go. So 0.9, oh man. 0.966 to the power of x. What is x? It's the 40, okay? So now we're gonna have to take our graphing calculator and enter it in. So everybody please do that. So let me go ahead and get my graphing calculator. Go to TI-35. So everybody please do this on your graphing calculator. Okay, what were the numbers again? Let's see. Get back here. Where are you, problem? There you are. So 45.7 and then 0.966. So I'm going to go 45.7 parenthesis 0.966 parenthesis to the power of 40. And I get 11.45. So I'm going to pick the one that's closest. That would round to B, okay? So we actually had to use the equation on that one this time. We could have used that blue curve, at least on my screen it shows blue. We could have used the blue curve, or we could use the model if there's several ones look like they could be correct on a blue curve. That's pretty much all there is to it, guys. Basically, when you read the question stem, also you need to figure out what they're asking you to solve for. They're asking for how many metric tons. What I always tell students is first determine what you're being asked to solve for, and then determine, are you being asked to solve for the X or the Y, right? well, what is the X? It's the years. The Y is the tons of oysters, and they're asking how many tons of oysters. So in a sense, we're being asked to figure out what Y is, and we're being given a value of X. So if you keep those two straight, that'll help you to avoid mixing them up. All right, so any questions on that? All right, so we can go over this one here. Again, they give like a little description of what's happening, or what's being tracked. They're talking about, that there's some corruption score and how it relates to GDP per capita. So I guess there's more corruption you have, somehow relates to that. And we're given a graph that shows the corruption score, over as it goes up, the GDP per capita goes up, and they give you an equation. So it's kind of like the one before, that you've got an equation or function, you got a graph, and you got a table. And again, most of these we're going to be making decisions based upon the function that models that data, or the graph that models it, not the specific actual values. Now, then it says, what does the y-intercept of the function represent? Okay, so then in words, they describe what it represents. So it's not actually saying what is the y-intercept. It's asking what the y-intercept represents. So this is a different type of question. Now, we should know that the y-intercept is the value of a function when x is equal to 0, right? So we should know that the y-intercept, x is equal to 0, and then whatever the y is the y-intercept. So if I look at the graph, I would say, hey, that when x is 0, it looks to be somewhere between 0 and 5,000. But again, I'm not being asked to measure it. If I look at the equation above, I don't know if you guys remember it, but when you get an exponential function, that first value is your beginning value. So 1640 would be the first, if the corruption score was 0, the beginning value would be 1640. That's because remember, it's like y equals a b to the power of x. A is always the beginning value when x is 0. But again, they're not asking that. So what are they asking then? If they're asking words, well, always remember this, and this is in general for anything. The y-intercept is, again, it's always where x is 0, which means it's the beginning y value, right? So if generically we say in general that the y-intercept represents where this function or the data begins, then we're going to look at something that in the answer choices that matches that, right? We're going to be looking at, first of all, the beginning of what? Well, the beginning of the beginning per capita when the corruption score is 0. So the way to kind of help you frame it in your mind is the beginning means that that's what the per capita is going to be when the corruption score is 0, basically. So now we're going to read each choice and try to match it up with that. So A says the increase in GDP for every increase. That's not what it is. That's not what the beginning value is. That's like the growth value. That's how it grows or decreases, but that's not the beginning value. The GDP capita with a corruption score of 0, that pretty much matches what I was saying, right? It's the value of y when x is 0. Well, what's y? Y is the per capita, right? X is the 0. X is the corruption, I should say. So B pretty much matches it up, but let's just check the others. C, GDP capita with the lowest corruption score? Not necessarily, although that's pretty close. It's not necessarily the lowest. It's when the corruption score is 0. So C is a little bit tricky, but in this case, the lowest corruption score is 17. We want the corruption score to be 0. So C doesn't really match it that well as B. D, the average per capita for every point in the corruption? No, that doesn't really say per capita GDP when corruption is 0. Okay, so again, this is a little bit tricky because basically they're testing your ability to understand the things that are being measured and what it means, what the y-intercept actually means. It's the beginning value of something when x, whatever they're measuring on the x-axis, in this case corruption, is 0. Okay, any questions on that? Okay, let me pause that real quick. Okay, so example number 3, if you've had a chance to read through it, again, it doesn't give us any tables or graphs, but it gives us the function or the equation that models it. And I guess it's still referring to the information above. Yeah. Okay. So it still is. So it gives us that same equation we already saw. And it tells us about that it's the number of years since 1900, and then Y is the amount of oysters. So the model indicates that there's 5.3 metric tons of oysters were harvested in what year? Okay, so this is a little bit different. What are we given? We're given an actual number of the metric tons of oysters. So we have to ask ourselves, is that the X or the Y? Well, that's the Y. So they're actually giving us the Y in this case. And now they're asking us about the year, which is the X, right? So we're actually, the first question was, they gave us, what did they give us? They gave us the X or the year, and we were trying to figure out the Y. Now they're giving us the Y and asking us what year it would be. Okay, now that means that this Y, so basically it's almost like this. You take that equation, you're looking for a Y that's 5.3 metric tons, and that's going to be equal to the 48.7 times 0.966 to the power of some value of X. Now there is algebra. Oops, I got to put it up on the screen. So sorry guys, that's what I just wrote down for you guys. Basically, that's what they're saying. They're saying 5.3 is equal to that 48.7 times 0.966 to the power of X. And they're asking us what year would give us 5.3 tons. Now I'm wondering if, well, anyway, so that's the equation we've got. So there's algebra. If you guys take algebra 2, you can actually solve for X algebraically. But you know what? We're not going to do that. What we're going to do is we're going to work backwards, meaning one of those answer choices will give us the correct answer. Meaning I can try for my X, since those are X's, I can try A, B, C, or D. Oops, I shouldn't be circling those. People think those are correct. Let me get rid of those real quick. Gosh dang it. There we go. So I can try those answer choices to see which one of them makes sense. So maybe, for example, starting with, I don't know, 1589. How many years is that since 19? You got to remember, we got to subtract years since 1900. That would actually be a negative number, wouldn't it? Well, anyway, what we'd have to do is we'd have to go, geez, what is that? So we'd have to go 1589 since 1900. That's going to give us a negative number. What is that? That's like that's 311 years. But it's negative 311. So that seems weird. You know what I'm going to do? I'm going to try B, because it doesn't seem like it's going to be 300 years ago. That doesn't seem like a reasonable answer. So let's try. So what would we do if we're going to try B? We'd think about how many years since 1900, right? So that'd be 64. So I'm going to take my calculator and I'm going to put it in for X and run it through that equation to see what I get. So go ahead and do that. Okay, I think it's 0.966, right? Let me make sure on that. 0.966. They really like that number. To the power of, what was it, 64? And I got 5.3. Check it out. Now, that is the correct answer, but let's just say we would have picked another answer like, get back here. There we go. Let's say I would have picked an answer like 1906. Then I would have plugged in 1906 minus that 1900, right? Years since 1900. I would have had to plug in a 6. So if I would have done that, it would have been 48.7 parenthesis 0.966 parenthesis to the power of 6. And I would have got like 39, right? So the point is, when you're doing it like these kind of questions, when you're trying to figure out which value of X gives you a value of Y that they're looking for, to 5.3, you just kind of do trial and error.